Hi, my name is Akeela and this is my Physics Lab 1. So the purpose of this lab was to study and examine the motion of an object moving in a straight line with a constant speed. The objective was to confirm the principles of constant velocity through video analysis and computational modeling. It was also to demonstrate how closely the observed motion aligns with the model's predictions. Two key concepts of this lab were Newton's second law and constant velocity, which says that when an object is moving at constant velocity, it means the object is traveling in a straight line with a steady speed, therefore the net force is zero. For the experimental setup, I pushed the chapstick to get it rolling across the table and recorded a video. The position of the chapstick was recorded frame by frame using the tracker software to gather timestamp position data. The recorded data was used to create an observed position versus time graph. After recording the video, I created a computational graph first using GlowScript code, and I started off by entering the mass of the chapstick, which was 0.004 kilograms, and then I entered the initial position and velocity, both of which were 0, and the delta t for my experiment was 0.025 seconds because the timestamps that I paused the video at were in very small increments, so I had many time frames. The total time of the video was 2.668 seconds, and the net force on the chapstick was 0 since it was moving at constant velocity. So to update the object's position, I used the position update formula, which says that the final position is equal to the initial position plus the velocity times change in time, which is why I have this here written ball dot position plus ball dot velocity times delta t. This is the position update formula written in my code. I ran the code. I got the position versus time graph that is seen here on the right, and the position versus time graph on the left comes from the tracker data. So the differences in these graphs are that graph from the tracker software shows a slight curve in the graph, which indicates the influence of forces that are not accounted for in my GlowScript computational model, such as friction or other resistive forces. Some similarities in the graphs are that both models depict the motion of an object over time, showing a relationship between position and time, which implies the fundamental concept of motion, displacement as a function of time, is consistent between the observed and modeled scenarios. There's also possible errors is that in our calculations we assume that there's no friction or air resistance acting on the system, which is the chapstick. However, the table, which is part of the surroundings, provides a frictional force to the chapstick. Another possible error is that the chapstick may not have traveled in a perfectly straight line, which would have changed the nature of the experiment because we're no longer conducting a constant velocity experiment since the change of direction affects velocity and acceleration. If we were to flip the axis, it would invert the signs of the position, velocity, and acceleration values in the x direction, but the magnitudes of these values would remain the same. The physical behavior of the chapstick, such as rolling in a straight line or experiencing constant acceleration, would remain unchanged. The interpretation would just be in the opposite direction. What does this mean? It means that the net force being 0 indicates that there were no unbalanced forces acting on the objects, confirming the model's assumptions of no friction, no air resistance, and constant velocity.